Hi everyone. So welcome to the second video of designing of a web crawler. So in the previous video, we have discussed about what is a web crawler, why do we use and where do we use a web crawler. We have also discussed about the requirements which need to be fulfilled to design a web crawler in our case, and we have also done some back of the envelope calculations. So in this video, we'll be looking into high level designing or the components which are used in designing of a web crawler. So we'll learn this through a flow diagram. We will introduce certain components and what are those components we will be describing along with the flow. So first component which we have is a seed URL. So what is a seed URL? So seed URL is basically the starting point of a crawling process. These URLs could be, let's say, suppose I'm in a university and university has various departments and it has various links and all. But let's say the domain name of the university, let's say XYZ University. Let's name it XYZ is the university name. This is the domain name. So this can be our seed URL, and following that I can go to various departmental links, like let's say it's an engineering college, then I can go to, like, say, mechanical, electrical, computer science and all from this domain link. So this can be my starting point or a seed URL for a web crawling process. So what is a seed URL? If we go into a little bit details, so it's a starting point for web crawling. So it's very much important to choose a good seed URL, because if I choose a good seed URL, then I can go to various links and more links and I can explore, and that would give me a better result for our use case. So these seed URLs can be achieved by dividing into various categories and subcategories, like let's say for a particular region. So my question would be like, how can I get a good seed URL, or how can I start with a good seed URL? So what I can do is, like, I can categorize maybe geographically. So let's say for a particular region, a particular website is being searched for a huge volume, or a large number of requests goes to a particular website. So I can put that website as a seed URL and start my web crawling process. Or it can be various sector wise, like health or sports or education, let's say e-commerce, and like that. So basically a seed URL is a starting point of the crawl process, and we should have a good seed URL so that our crawler can utilize it to traverse as many links as possible. And how to get a good seed URL? You can categorize into various subcategories, like maybe you can find it geographically, or you can divide into various sectors and start with that seed URL. So now once I have the seed URL, what I will do, I will have to download this web page, right? So before downloading this web page, what does web crawler does? It puts into a data structure, let's say a queue. So I am starting with a seed URL, so there may be multiple seed URLs, right? So let's say seed URL 1, seed URL 2, and they are put into a data structure. Let's say it's put into a queue, and first in first out is followed as it is in queue. So the web pages which has been discovered but not yet visited or not yet downloaded, they are put into a data structure or a system which is called URL frontier. So our seed URL web crawler puts into a data structure, and this section is called URL frontier. So we will be looking into details about URL frontier in our deep design video section. So we'll be discussing about URL frontier in details. So for the time being, what is a URL frontier? If I describe, it is like our web crawler has discovered links, in this case like seed URLs, but pages not visited yet or downloaded yet. So what happens? put these links rather in a data structure, say queue, or maybe anything which you can implement for your use case. And this data structure or system is called URL frontier. Okay, so now I have a URL frontier. After that, I need to download the web pages. Since I have the links with me, they are processed, put into the queue, and now one by one I take out from the queue and I download the web pages. For that, what we use is a HTML downloader. Right? So HTML downloader, what it does, as the name suggests, it's very obvious. HTML downloader. So it downloads the web pages or the HTML content. If you remember, this was one of our requirement which we had discussed during discussion with the interviewer session. So downloads the web pages or HTML content. HTML downloader, this is what it does. And how it does, using those links, URL links. And for that, to download, to connect with the URL links, we need a DNS resolver. So this is another component which is included in the designing of web crawler. So HTML downloader basically interacts with a DNS resolver. So DNS resolver basically takes the URL, gives back the IP addresses so that the web pages can be downloaded, right? So once the web pages are with us, so I'll just quickly draw what we have seen till now. We have a seed URL. It is put into a URL frontier. From URL frontier, we take out the links and download the HTML contents using a HTML downloader. It takes the help of a DNS resolver to get the IP addresses of the URL links. And now next we have is content parser. So what is this content parser? So suppose my HTML downloader has downloaded the web pages, and suppose they are some malicious web pages or trash web pages or unresponsive web pages, right? So a content parser, what it does, it checks malformed web pages. If yes, then disregard that. So that basically helps in preventing storage wastage, right? So basically there is some malformed web page, and why should we be storing those web pages for our use cases, right? So it helps in preventing storage use case. So after this HTML downloader, I have a content parser. So now I have all the valid web pages with me right now. After this, I'll check whether I have already seen this content or not. Whether I have already seen this content or not. So what is this? This is basically a data structure which is used to eliminate data redundancy. So for that, what we have, so if I draw a flow diagram, I'll check whether this content is seen or not. And how will I compare with the web pages? They are actually stored in a content storage. So what is this content storage? If I just briefly describe, this content storage, due to huge content, as you might remember, we have to have 30 petabytes of data for 5 years if our web crawl service is working, and we are visiting web pages at a rate of 1 billion requests per month. So in that case, we have to have a huge content, so memory would not suffice. So we'll have a mixture of both. One, we have memory for faster lookup for more popular content which is frequently queried, and another we have the disk to store the entire content. So this content storage will have the HTML pages. Now returning back to content scene. So what we'll do, we have an HTML page, we compare two HTML pages and check if they are similar or not. If they are not, then we store that content, or else we disregard that content. So how do we compare? So next question would be like, how we compare two web pages, HTML web pages. So one would be like we go character by character, but that would induce a high latency, that would be a slower method. So in that case, what we do is we compare the hash values of the two HTML pages, and if they are same, then basically they are the same content, so we disregard that content, or else if they are not, then we put that content into the content storage. So now I have a situation like this. So if you remember seed URL, then I'm not writing in full, you now have an idea. URL frontier, then I have this HTML downloader which interacts with DNS resolver. Now I have content parser. After this content parser is done, content scene or not. So it checks whether this content is seen or not. If not, it puts into the content storage. And now next thing is, from this content storage and content scene, I will go to another component, which is the URL extractor. So this URL extractor, basically, as the name suggests, it visits the HTML content page, visits the HTML pages stored in this content storage, and extracts links mentioned in this pages. And after the links are extracted, we now go to URL filter. So once the links are extracted, so if you want to see an example of how an URL extractor works, I can show you an example. So let's see an example. So here if you look, so this is an HTML page and there are some referred links in these pages. So these links are actually extracted and they can be seen like this. So it's visible like this. Okay. So now after this URL has been extracted, it goes to URL filter. So basically this filters the links if they are banned or not, or if they contain some file extensions which are not allowed and something like that. So it filters the links, and after that, once it's filtered, it goes to another whether this URL has already been seen or not. And how do they check that? For that, we have an URL storage. So it checks in the URL storage whether that URL is present or not. If it is present, then it disregards that URL, or it doesn't go forward with that URL. It also checks in the URL frontier, which we discussed after the seed URL section, seed URL part, whether that URL is currently present in the queue or not, in the data structure or not. That is need to be explored. So if it is also there, it discards this URL. And once if they are not all present, then this URL is first time seen. If this URL is seen for the first time, then it again sends back. If the answer is yes, so if the answer is yes, then discard this. If no, if URL is not seen, then send this URL to an URL frontier, and again repeat this entire process. So this is basically a high level overview of how a web crawler works. So basically we have a seed URL, we have a number of seed URLs which are put into the URL frontier data structure based on some priority or any other algorithms which we might implement. After that, from that URL frontier, it takes each of the links one by one, downloads the web pages using the DNS resolver and HTML downloader. After these pages have been downloaded, it is parsed to check whether their page has been crashed, or page is unresponsive, or there is a malformed web page, in order to prevent storage wastage. After that, once it's been parsed, it goes to check whether this content has already been seen or not in the content storage. It compares to HTML web pages and checks whether they are similar or not. If not, then that URL is extracted. After the URL has been extracted, it passes through a filter to check whether this URL is valid or not. There are some valid file extensions and all the criteria, security reasons. After that, when the URL has been filtered, it also checks again that whether this URL has been seen or not. Like, is it already present in the URL storage, or if it is present in the URL storage, then discard that URL, or if it is present currently in the URL frontier that will be explored in the next section, then you can also discard that URL, or else move that URL to the URL frontier and repeat the entire process. So this is overall a high level designing of how a web crawler works. So in the next video, we will be diving deep into the details of the implementation of each of the section. So thank you for watching this video. I will see you in the next video.